Well, howdy, folks, and let us start with Chapter 6. Chapter 6? How about Unit 6? Yes, Unit 6. And in this unit, we want to learn about reactions, and we want to learn about the types of reactions. Want to learn about balancing. We want to learn about something called redox. And to start with, though, we want to just understand the basics of a chemical equation. So let us start here. Consider the reaction. Okay, I have a reaction of solid sodium with water to form aqueous, yikes, that's a new word, sodium hydroxide and hydrogen gas, right? The unbalanced equation for this reaction. All right, I think we need some notes. Here we go. So I said this unit is about reactions, chemical reactions, and one part of chemical reactions is the writing of them, and we'll call those what? Chemical equations. Good. And I always like to start with what, ladies and gentlemen, my definitions, right? So let's give a definition of a chemical equation. Is simply a representation of a chemical reaction. Okay. So it's the way that I show on paper what is happening in a chemical reaction. Good. And what is included in here? Hey, we identify the reactants and products. What else might we see in a chemical equation? The states of my reactants and products, the number of molecules, and oops, I can't spell, number of molecules and atoms comprising my reactants and products. Okay, so those are the kinds of things, and I guess finally symbols indicating details about the reaction, such as at what temperature it takes place and that. But to simplify it, it is just a representation of a chemical reaction. Good. Now, I use some things here that maybe you don't know about. Let's talk about, excuse me, I don't want to bring this off of reactions. I want to bring it off of chemical equations. Let's talk about the components maybe. What are the components? What makes up components of a chemical equation? Okay, well, there are essentially two components, right? There are reactants and there are products. Good. And usually they're separated by something that looks like that. And so what are my reactants? Reactants are substances which are consumed in a reaction. And my products are substances which are, this is earth shaking here, right? Substances which are produced in a reaction. I don't suppose this is new to any of you, but just to give you some substance, notice where these things lie. Reactants are on the left side of my yield arrow, and products are on the right side of my yield arrow, or on the pointy side of my yield arrow. It's not always left and right. I have to be careful here. The products are on the pointy side of my arrow, and the reactants are on the what? Non-pointy side of my arrow, or the feather side of my arrow, if that were a feather. Okay, good. Other things that we need to know before we can start making our chemical equations are symbols. We use some symbols. And what symbols are used in chemical equations? Well, we have some that tell us about the states of our reactants and products. And there are things like I have what? A solid, a liquid, a gas, and I have something called an aqueous solution. Now that's, yeah, you might, it's really a solution. It's not a state. And what does this mean? For us, an aqueous solution is It means that it is dissolved, the substance is dissolved in water. Not only is it dissolved in water, it is we mentioned this before, right? Solutions are what? Homogeneous mixture, right? So we're talking about a homogeneous mixture of our substance in water. So those are the four, we'll call them states or pseudostates. And how do I represent these? Well, S for solid, L for liquid, G for gas, and aqueous, AQ. Now, there are a couple others that I use. For solids, I can also use a down arrow. Sometimes it's used to indicate a precipitate, right, which is a solid that is formed in a reaction. An up arrow for gas. Good. How about some more symbols? We have several symbols related to my yield arrow. I could have just a normal arrow, and that just means, hey, yield. I can have an arrow that looks something like this, or sometimes people write it like this. That means this is a reversible reaction. That means the reaction occurs in both ways. It occurs from left to right and occurs from right to left. I can have something like a yield arrow with a delta on top. That means reaction requires heat. I could have an arrow with a temperature, 298 K for instance, on top of it. On top of that, that means the reaction occurs at 298 K. What about something like, hey, I can have a 1.5 ATM over my arrow. What does that mean? That means my reaction occurs. What is ATM? That's the pressure at 1.5 ATM. And then I could have an arrow, and there might be something like MnO2 over it. And this is representing a catalyst. If I have a catalyst, the catalyst goes over my arrow, and that means my reaction occurs in presence of my catalyst. In this case, my catalyst is what? MnO2. Yay! Good. I think we can answer our question. Number one, the reaction of solid sodium. Aha, I got sodium, and I know it's solid. With water to form. Hey, to form, that's going to be my yield arrow. So with water plus water. Now, we all know water comes in three states. Ice, which is, of course, the solid. Gas, what's gaseous water? We call it what? Steam. Steam is I guess I should reverse these, keep my logic in order, right? I have ice and I have steam, and steam is what? A gas. And then what do we call liquid water? Hey, we just call it water. And so that's L. So whenever we see the term water, we're assuming it is in what state? The liquid state. Good. H2O. And folks, you're going to see me start writing water this way, HOH. And you'll figure out why a little later. But I'm going to start writing water HOH. To form sodium hydroxide, NaOH. Remember, sodium, when it forms an ion, is +1. Hydroxide, you've memorized, is -1. So there would be a 1-to-1 ratio. It's aqueous, so I put an AQ, plus hydrogen gas. And hydrogen gas is H2. Now, why do I say H2? Let us come in here and let me give you some tips here. Let's see, I'm going to run this off of my chemical equations. Let's go with a different color, blue. And we're going to go this way. Yes, I know that messes you up if you're watching the subtitles. And we want to talk a little bit about diatomic species. There's a group of diatomic molecules, diatomic elements. There are a group of elements which require, they're not stable alone, okay? group of elements not stable as single atoms. Okay, there's a group of these. And must be either in a compound or paired with another element, another of its atoms. All right? And what that means is, I know that's a little Byzantine, this definition, but what it means is things like hydrogen don't exist like H. That does not exist in nature. It's just not stable. It either is going to be in a molecule or an ion, let's say potassium hydride, or it's going to be H2. So when you see the word, hey, it reacts with hydrogen, it must be written as H2, not H. H just is not stable. Got it? And what are those? There are 7 that I want you to know. 7, I think. Iodine, bromine, chlorine, fluorine, oxygen, nitrogen, hydrogen. Or as I remember them, I brought clay from our new house. I brought clay from our new house. That means these guys either have to be doubled up as you see them here or in a compound. In a compound. Got it? I never see I by itself. I never see Br by itself in an equation. They must be I2, O2, Cl2, or they must be in a compound. It's okay to have one chlorine as long as it's in a compound, but you'll never see just Cl written that way in a typical compound. It has to be Cl2. Good. I brought clay from our new house, and if you're more of a visual person, look at it. It's this group right here and hydrogen. Those are my diatomic molecules, my diatomic elements. Got it? Okay. Moving on. You guys try this one. The reaction of solutions. Bring me back when you're ready. All right, here we go. The reaction of solutions. Aha, solutions, that means I have some aqueous stuff, barium hydroxide and ammonium carbonate to form. Hey, there's my yield. Carbon dioxide gas, water, and solid barium carbonate. Okay, I think by now you realize you have some problems if you haven't done what? If you haven't memorized your polyatomic ions, this unit is going to be very challenging for you. So you may want to go back and relearn that. If you're not good with your naming, once again, you better go back and relearn that unit. All right, here we go. Barium hydroxide, barium is a 2 plus. When it forms an ion, hydroxide is a -1, so it's barium hydroxide. It's aqueous plus ammonium. Hey, ammonium is a +1. When it is, ammonium, when it is an ion, it always is an ion. Carbonate is a -2. There we go. It's aqueous. It's going to yield. I'm going to draw my yield sign here. What? Carbon dioxide gas plus water. If it's water, what does that mean? Nice plus. If it's water, that means it is liquid plus barium carbonate solid. Yeehaw! Happy big. Oink, oink. Yay, yay. Let's give him a smile. Yoink, ears. Got to have at least one ear. Give him a wing and some feet. Woo! And hoofs. Okay, so there we go. He doesn't look so happy. Let's give him a bigger smile. How's that? Yay! He needs back feet too. Okay, so there you go. Good job. You get a pig for your efforts. Next, consider the reaction of ethene gas and hydrogen gas in the presence of a platinum catalyst to form, not to form ethane. All right, let's do this together. Well, you guys can do this. I'll give you a few minutes. Bring me back. Okay, ethene, aha, that looks like organic, sure. Ene implies what? I have a double bond, and you guys will recall that that is CN, H2N, F. That implies what? I have two carbons, so that means I start off with C2H4. It is a gas plus hydrogen gas. Aha, hydrogen. It's a diatomic molecule. I brought clay from our new house. That means it can't be just H. It's got to be H2 gas in the presence of a platinum catalyst. Hey, where do I put a catalyst in my reaction? Over my arrow to form ethane. Ethane, that means it's an alkane, CnH2n plus 2. So Cn is equal to 2, C2H6 gas. Excellent. How many of you had that right? Boola boola. Cool. And this one here. Consider the reversible reaction of nitrous acid and water to form the hydronium ion and the nitrite ion. Egads. Do you guys think you can do it? All right, give it a shot. Well, reversible reaction. So that means what? I have a special kind of arrow. That means I'm going to have an arrow that goes in one direction and an arrow that goes in the other direction. Nitrous acid. Oh, nitrous acid, us. That means it comes from what? Nitrite. Ite means us. So that means I have H. Nitrite is NO2. My acids are always aqueous when they're called acids. And water yields to form hydronium ion, H3O plus, aqueous. I guess I should have said these were aqueous. And the nitrite ion. Yes. Now, I should have told you that these were aqueous, my fault, but to form aqueous, I knew that. And aqueous. There you go. So, any questions? Let's call this meeting, and next time we will continue with our not unbalanced but balanced equations. Auf Wiedersehen.